Hello, my friend. Welcome to my channel. So today I'm going to talk about the two-tailed hypothesis testing for population mean mu. So this is the example. A research foundation reports that the average wind speed of a certain city is 8 miles per hour. To see if the average wind speed of that city has changed, a researcher selects a sample of 32 days and finds that the average wind speed is 8.2 miles per hour. The standard deviation of the population is 0.6 miles per hour. At alpha equals 0.05, is there evidence to support the claim? So as you can see, we are looking at a change. So that means this is a two-tailed test. First, let's figure out the null hypothesis and the alternative hypothesis. So here the claim is not equal case. So mu is not equals 8. And the null hypothesis is mu equals 8. So the claim is the alternative hypothesis. So let's look at the information here. The sample size, simple n equals 32. And the average of the sample, which is x bar, equals 8.2 miles per hour. And the population standard deviation is given, which is 0.6. So we know this number is known. So therefore, we can use these scores. Okay. First, let's find out the test statistic of this testing. Z naught equals x bar minus mu over sigma over square root n. X bar is 8.2 minus 8. 8 is the hypothesized value. And sigma is 0.6 divided by square root of 32. So this number equals 1.89. So this is our test statistic value. So in this problem, I'm going to use critical value method and the p-value method to find the decision of this testing. So let's look at critical value method. We have to look at alpha value here, 0.05. So this is two-tailed test. Since it is two-tailed test, we need to divide this alpha by 2. So alpha over 2 is 0.025. So that is, in this case, we have two tails now. So the left tail is 0.025 and the right tail we have also 0.025 area. So now we have two cutoff values. One cutoff value is over here, another cutoff value over here. So then this region is non-critical region. So here we do not reject. This is non-critical region. Non-critical region. These tails, the left tail and the right tail, are the critical regions. So let's find out these two critical values, this value and this value. So if you can look at the Z table, locate this area 0.025. 0.025 inside the table. And then you can locate the Z-score. Z-score is negative 1.9. Second decimal place is 6. Like this. So therefore, this number here, critical value is negative 1.96. So as you know, this distribution is symmetric around 0, right? Around center. So therefore, if this one is negative 1.96, so this number is positive 1.96. So we have both critical value. One is negative and the other one is positive. So let's find out the p-value. To find the p-value, here we need to consider two tails. If you consider the probability z-score less than z0, extreme case less than test statistic value, then that is the probability z less than 1.89. So 1.89 is somewhere around here, 1.89. So this probability represents this area to the left. If you look at the z table, you will see 1.96, 1.8, and the second decimal place is 9. Then you will see the area is 0.9706. So then this area is 0.9706. But we need the tail, right? P-value represents tails of the distribution. So this tail can be found 1 minus 0.9706, which is 0.0294. So this is the probability that z scores less than 1. This probability is this tail. Okay? So this one equals 0.9706. So this is our tail. And then since we are considering two tails, we have to double this value to get the correct p-value. So the p-value equals 2 times 0.0294, which is 0.0588. So that means we have both tails. So one tail is 0.0294 and the other tail is also 0.0294. So both left tail and the right tail gives us the p-value, which is 0.0588. So now we have the critical values and the p-value. Let's see how to make the decision. So as you can see, look at the test statistic value, 1.89. So 1.89 is between 1.96 and negative 1.96. So it falls somewhere around here, right? 1.89. So as you can see, this 1.89 falls in the non-critical region. So in that case, we fail to reject the null, which is H naught. So according to critical value method, we fail to reject the null. Let's look at the p-value. The p-value is 0.0588. So we compare this p-value with alpha. Alpha is 0.05. Which one is bigger? The p-value is bigger, right? If the p-value is bigger than alpha value, then we fail to reject the null, H naught. Because this side, so left tail, you have 0.0994, right? Then one tail, you have alpha over 2, which is 0.025. So as you can see, 0.025 is less than this number, right? So it is less than 0.025 is somewhat like here, right? less than this 0.0294. So that's why we reject the null hypothesis here. And then you can write down the conclusion here. There is not enough evidence to conclude that the average wind speed is different from 8 miles per hour. So that's the conclusion of this hypothesis testing. So I hope you understand this question. If you have questions or concerns, please comment. And thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.